This is Aditya from Crackverbal. Before we start, a quick audio check and video check. Am I audible? Guys, can you hear me? Perfect. Great. So, a quick introduction about me. Um, you know, I'm an engineer by profession, like I think most of us in this forum would be. I'm a pass out from MS Ramaya Institute of Technology, the year 2009. And I worked for Infosys for a couple of years, worked in a company called Mu Sigma for a couple of years. And then I got into, coaching students for GMAT and GRE. That was it was just a happenstance. And I've continued to do so, right? So I head the quant division here at Crackverbal, and we had a good initiative, tie up with GMAT Club to host some webinars, add some value to things. So I'm going to speak about inequalities today, right? It's one of the most, say, dreaded topics along with permutations, combinations, and probability on quant. And I'm going to give you like a different perspective, right, of how you approach inequality questions. Because the problem with inequality questions is if you start approaching the question with numbers, right, it starts becoming too confusing. But if you bring in reasoning, right, and know where to use and how to use the numbers, things become very, very simple. So what I'm going to do is I'm only going to focus on one process, and that's a reasoning procedure of or analyzing procedure of solving any inequality question. Okay, and even if it's a 700 level one, I am not going to put in values at any point. Okay, if somebody in the chat window asks me to put some values to justify certain things, I would, but most of the cases, right, I'm not going to touch values at all. So can we start the session? Everybody ready for it? I'm going to share my screen. I'm going to toggle between two screens. One is a sketchbook where I'm going to write a lot of stuff. And what I write on the sketchbook is like, a lot of pointers. I'm going to actually teach you some aspects of concepts rather than just jumping into questions, right? And whatever concept I give you, right, I'm going to then bring in a question so that you apply whatever you've learned on that concept onto questions. So ready to start? And all of you all ready to start? Perfect. So again, a quick check, guys. Can you all see my screen? Because I'm going to toggle between two things in my screen. So if you're able to see my screen, you should be able to see, um, yeah, a sketchbook. So all of you all, can you all see my screen? No problems. Perfect. So I'm going to start. Now these are some, I'm going to toggle also between the PPT and the sketchbook so that the questions are always on the PPT. You can always view the questions, and whatever notes I write will always be on the sketchbook, right? Just before we start, three ground rules to the session. We want to make it as organized as possible. So any responses that you have, please put it in the chat window. But my advice is hold on to whatever doubts you have. I'll try to keep a 15-minute Q&A towards the end so that I cater to all the doubts. I will try to answer whatever questions I can on the chat window as y'all are solving. But if you find some issues, you have a lag of more than 10 seconds, quickly ping me in the window or quickly log out and log in. It should fix the issue. Okay. Now, the agenda of the session, right, is going to be threefold. First, I'm going to basically expose you to the basic properties of inequalities. These are like important properties, right? It's not what you studied in school only. I'm going to add to certain things. The second, I'm going to give you a three-step process to solve hard inequality questions. And finally, I'm going to work with example questions, okay, or illustrative examples to work with things, right? So this is what I have planned, right, for the agenda of the session. So let's kickstart things right away. Now, before I go into slightly heavier concepts of inequalities, there are three basic rules of inequalities that everyone should know. The first, you can always add or subtract any quantity on both sides of the inequality, and the inequality sign remains unchanged. Right? What you need to keep in mind, right, is this: when you work with an inequality question, when you're simplifying the entire question, right, don't simplify it the same way as you would for equality questions. There are certain rules for inequalities. Make sure you follow those rules. So the first rule is, you can add anything you want, you can subtract any quantity you want on both sides of the inequality, and the inequality sign remains unchanged. Right? So for example, when I gave you x plus 5 is less than 8, the goal here is to solve for x, right? So I'm subtracting 5 from both sides, so x would be less than 3. Very easy, right? Basically, this property is what you do with equalities as well. Second, you can always multiply or divide both sides of an inequality with a positive quantity, and the inequality sign remains the same. Right? If you multiply or divide both sides with a positive quantity, the inequality sign always remains the same. So if I give you 2x is less than 4, I'm going to divide both sides by 2. So x will be less than 2. And the third golden rule of inequalities is, suppose I give you minus 2x is less than minus 4. You can also multiply or divide both sides of an inequality with a negative quantity, but the inequality sign will always flip, right? So if I divide both sides by minus 2, I basically have to flip the inequality sign and say x has to be greater than 2. So just putting some ground rules here, I want all of you all to understand that these are the three basic rules that the entire inequality topic is based on. And what I'm going to do now, if you all are clear about the three basic rules, I am now going to give you some add-ons, right? You can take them as pointers, you can take them as rules, but those add-ons will be key to answering harder questions. Okay, with the first bit, all of you all, I'm sure everybody would be clear with the first bit. Bharat, see, we are only speaking about inequalities here, right? If I have to speak about inequalities with absolute values, no, then I'll have to explain the absolute values bit as well. So maybe in another webinar when we are not when we have some more time, right? I can give you an add-on with absolute values, but my focus here is entirely going to be on inequalities. Okay. So all of you all okay with the first bit, guys? Clear about the three basic rules on which this entire topic is based on? If you can quickly type in the chat window, I can move on and focus now on the harder ones. Okay, and make sure that whatever I'm saying for the harder properties, you note down, because that will be important. Guys, quickly, can you confirm? Perfect. Okay, so now, so my question to all of you all, can you multiply or divide both sides of an inequality with a variable? Right? Think about it. Can you multiply or divide both sides of an inequality with a variable? For example, if I give you x by y is greater than 1, can you for sure say x is greater than y? Guys, quickly type in the chat window. Can you multiply or divide both sides of an inequality with a variable? Perfect. So Saurabh says no, and it's absolutely right. You should never multiply or divide both sides with a variable until you know the sign of the variable. The reason we cannot do this, and this is one of the ideal traps that people will fall for on inequalities, the reason we cannot do this, because the second and the third basic property of inequality says that when you multiply both sides with a positive value, right, the inequality sign remains the same. But if you multiply both sides with a negative value, the inequality sign has to flip. So when we have x by y is greater than 1, we just cannot take the y to the right hand side, because you're basically multiplying both sides by y in that case. And since we do not know the sign of y, right? I don't know whether I have to flip the inequality sign or keep the inequality sign the same. Make sense? So the point I'm making is when you get terms like this, right? S divided by xy is equal to 2s or less than 2s divided by say zr. The biggest trap, right, that students will fall for is they would cancel the s on both sides, and this is something that you should never ever do in an inequality. Also, you should never cancel variables on both sides of an equality as well. Now you'll be wondering, why is he saying that you cannot cancel variables on both sides of an equality? So if I give you this relationship, AB is equal to BC, my question to all of you all, can I cancel B on both sides and say that A is equal to C? All of you all, can anyone answer? Can I cancel, if I give you AB is equal to BC, can I cancel B on both sides and say A is equal to C? Is that logically right, or would it be wrong? If you're telling me no, then can you give me a justification of why not? No, Gulshan, it's not only on the GMAT. Basically, it's the rule of algebra, right? Exactly, right? Because B can be zero. So what you cannot do is cancel B on both sides and say A is equal to C, because B can also take a value of zero. So whether you're dealing with an inequality or an equality, right? One cardinal rule is you never cancel variables on both sides. You can't do it for an inequality because you don't know the sign. You can't do for an equality as well because the variable can take a value of zero. But if it's mentioned that B need not be equal to zero, then you can cancel B on both sides. The best way to work is to always take things to the right hand side and simplify, right? So either B is equal to 0 or A is equal to C. These would be the solutions to that equation. So the most important bit, you can never cancel or never multiply or divide both sides with a variable until you know the sign of the variable. If the sign is known, right, then you can definitely do it. So if I give you x by y is greater than 1 and I mention that y is greater than 0, then I can definitely multiply both sides by y because I know the sign for y. Even if it is y less than 0, I can still multiply both sides by y and get a relationship between x and y, right? So first extra point, keep in mind, you can never multiply or divide both sides with a variable. You should never get into the habit of canceling things, whether it's an equality or an inequality. So my question to you all, and I want all of you all to think about this, can I multiply or divide both sides of an inequality by a squared term, say by x square? Think through, can I multiply or divide both sides of an inequality by a squared term, x square, say? Anyone? Is it possible for me to do that? Multiply or divide both sides by x square? Now, this is the big trap, right? People will say for sure you can multiply or divide both sides of an inequality by x square because x square is positive. And this is one big trap that the GMAT always tests you on. Keep in mind that x square is not positive. X square is non-negative. The meaning of this is x square can also take a value of 0. So if you have the urge, right, of multiplying both sides of an inequality by x square, you have to understand that it has to be under the constraint that x should not be equal to 0, because x can also take a value of 0. So make sure that when you're working with squared terms, don't assume that a square is always positive. A square is always non-negative. That means it can be 0 or positive. Make sense? Perfect. Utkarsh, see, X could be a complex number. We don't deal with complex numbers on the GMAT. Okay, so on the GMAT, we only deal with real numbers. So that is something that you should rule out immediately. Okay, so don't get into complex number territories itself. All right. So, guys, keep this in mind. Quickly reiterating the thing to remember, never multiply or divide both sides with a variable until you know the sign. Best thing to do is to take things to the left hand side and factorize. And third, don't assume a squared term is always positive. A squared term is non-negative. Okay, so this is a point that you'll have to, note down, because most of the traps will be, with zero and you forgetting, to test for zero. Okay. Now, another important concept, and that's the concept of squaring inequalities. So my question to all of you all, suppose I give you x is less than 3. Can I square the inequalities? Can I square both sides of this inequality and say x square is less than 9? Would that be okay to do? If it's not okay, then how do I square both sides of an inequality? Anyone? If I give you x is less than 3, what would be the range for x square? Let me be more specific. If x is less than 3, what must be the range for x square? Guys, see, you see what points I'm bringing in? I'm bringing in points where you would be tempted to do exactly the same manipulation that you would do with equalities, right? So I'm just basically telling you, you have to stay within the purview of certain rules, right? Bring all to one side and then try x minus 3 is less than 0. Shashwat, how will that help me out, right? If I bring it all to one side. Okay, so listen to me, please. Okay, and I want all of you all to follow this process, especially when you have the urge of squaring inequalities. The best way to square any inequality is to picturize the range on the number line. Okay, and you see how I'm going to do it. Very important. We'll look at a couple of questions which test you on this. The inequality given to me is x is less than 3, right? So if I'm going to picture it on the number line, this is how it would look. This is 0, this is 3. I'm basically asked to consider all values from 3 onwards, not inclusive of 3, up till minus infinity. Okay, I want all of you all to picture this in your head. Okay, do it in your head and visualize this. X less than 3, you're considering all values from 3 onwards to minus infinity. And what I've asked you to do here is I've asked you to square all values from 3 onwards, non-inclusive of 3 obviously, up till minus infinity. So you're squaring all values from 3 to minus infinity. So think about it. If you're squaring all the values on the number line from 3 onwards to minus infinity, what will be the range, or what will be the greatest value that you can get for x square? Think about it, guys. You're taking all values from 3 onwards to minus infinity and you're squaring all of them up, right? What would be the greatest possible value of x square? Think about it, right? Don't give me the answer directly. Many of you are giving me the wrong ranges, right? Think about it. What do you think would be the greatest value for x square? Answer that first. Infinity? Perfect. And what do you think would be the smallest value? You're traveling to all numbers from 3 onwards to minus infinity and squaring them up. So you said that the greatest value would be infinity. Perfect. I agree with you on that, because minus infinity whole square would be infinity. But what do you think would be the smallest value for x square? The smallest value of x square would be 0 square, which is 0. Because when you're traveling from 3 to minus infinity, think about it, right? If I consider, say, 2.9, 2.8, then 2, then 1, then 0, then minus 1, minus 2, minus 3, till minus infinity, if I square all of those values up, all of those values are going to be positive. The smallest value I can get is 0. So when x is less than 3, the range of x square should be greater than or equal to 0. 0 will be the least value that you can get, and infinity would be the greatest possible value that you can get. So what you have to understand is, when you're squaring inequalities, right, you can't square inequalities directly. You'll have to picturize the range on the number line and then figure out what the range for x square is going to be. Okay with this, guys? All of y'all? Right? Many of y'all are saying 4, many of you say just less than 9. Those are not right. Keep in mind, you're taking all values from 3 to minus infinity. And if you're getting confused, right, just chart it out. 3, 2.9, go on like that to minus infinity, square it. See what happens. Okay. Shriyati, it's not going to be less than 9, right? It's not going to be less than 9. If you're telling me less than 9, then you're going up to minus infinity, and you can't tell me a square is going to be negative, right? Okay with this, guys? What I'm basically saying is if you're considering all values from 3 to minus infinity and squaring them up, the greatest value you'll get is when you have minus infinity squared. And the smallest value you'll get is when 0 is squared, right? So you can get a possible value of 0, 0.1, 0.2, 1, 2, 3. So the greatest value is infinity and the smallest value is 0. I hope all of you are understanding this. Yeah, so good question, right? If you are doing the cube, what will the range be? The best part about cubing, right, is you don't need to worry about anything. You can just cube the inequality directly. So if somebody asks me if x is less than 3, what should be the range of x cube? I will directly say x cube is less than 27. You know why? Because cubing, right, or taking an odd exponent is not going to change sign. But taking an even exponent is going to change sign. So since I know it's changing sign, right, that's why I'm plotting it on the number line and then figuring out the range. Got it? Perfect. Anudeep, you're right? It's going to be x cube is less than 27. Simple as that. Perfect. So let's try one more. Let's change the ranges slightly, okay, so that you get a hang of this. So I want all of you all to try this out, okay? I want you to take the range x is greater than 3. I want you all to draw out the number line, picturize the range on the number line, and you tell me what should be the range for x square. Okay, think about it, guys. What I've given you is x is greater than 3. And I'm asking you, what should be the range of x squared? Don't directly do things, plot them on the number line, please. Understand the visual representation, then tell me the range for x squared. We'll come to that, Azharul. I'm going to take all the values, okay? I'm going to take x greater than 3. My next two examples will be x less than minus 3, x greater than minus 3. And I'll also take a closed range as well so that you understand this, okay? Perfect. So most of you all have given me the right answer, right? X is greater than 3. If I visualize it on the number line, this is 0, this is 3. And I'm going to consider all values from 3 onwards to infinity. Remember, it's non-inclusive of 3. So if you picturize all values from 3 onwards to plus infinity, if you're squaring all of these values up, the greatest value for x square you would get would be infinity square, which is infinity. And the smallest value you would get is something slightly greater than 3 square, which is 9. So x square has to be greater than 9 here. Make sense? All of y'all? Perfect. 9 is not a possible value, right? So I'm not including 9. So I'm just saying x square has to be greater than 9, right? Yeah, x square greater than 9 basically involves anything greater than 9, right? So you don't need to worry about the decimal form. Greater than 9 is non-inclusive of 9. Perfect. So since somebody asked me this, let's work for these two as well. So first let us work for x is less than minus 3. So if I give you x is less than minus 3, again, figure out what should be the range for x square. All of you all give it a shot. Guys, I'm saying x is less than minus 3 now. And again, my question is, what should be the range for x square? Try it out. Perfect. X is less than minus 3. So let's again visualize it. 0, minus 3. You're considering all values from minus 3 onwards to minus infinity. And what you're doing with all of these values is just squaring them up. So if you're squaring them up, minus 3 to minus infinity whole square would give me the greatest value, that's infinity. And the smallest value would be something slightly greater than minus 3 whole square. And minus 3 whole square would be 9. So x square has to be greater than 9. Make sense, all of y'all? Perfect. Any doubt in this? Perfect. So I think somebody asked me a doubt on that. Is your doubt clarified? Okay with how you work for x is less than -3? So let's take one more so that you get a holistic understanding of things. What if I give you x is greater than -3? And again, I ask you what should be the range for x squared. Guys, why don't you try it out? X greater than -3. So what do you think the answer there would be? Perfect. X squared, x is greater than -3, so it has to be -3, 0. It's going to be from -3 to plus infinity. So -3 to plus infinity, the greatest possible value will be infinity, and the smallest possible value will be 0. So x squared has to be greater than or equal to 0. Make sense, everyone? Because if you understand this, you will be able to understand even when I work with finite ranges, right? So what we dealt with here were infinite ranges, you see, because they represent infinite portions on a number line. So the takeaway is don't directly square inequalities, right? You'll have to picturize the range on the number line and then you'll have to work with things. Okay with this, guys. So last example before I move to the next bit. Actually, instead of moving to the next bit, we'll look at an example of a question and then we'll try to get to an answer. There's something else I want to put across here. So if I give you a finite inequality, right? Say something like -4 is less than or equal to x is less than or equal to +9. You see, I'm giving you a finite range. And my question to you is, if x is between -4 and +9, inclusive of -4 and +9, what would be the range for x square? Right? What would be the range for x square? Perfect. Right? Great. So most of you all have given me a good answer. Think about it, right? Picturize it in your head. So -4, we have 0, and we have +9. So basically, you're considering all values from -4 to 9. So whenever values from -4 to 9, and you're squaring all of those values up, ask yourself, what would be the greatest possible value for x square? So the greatest possible value for x square would be 81, 9 square. Now the trap will be saying the smallest possible value will be -4 whole square and put 16. But you need to understand that when you're going from negative to positive, you're crossing 0, right? So the smallest possible value would be 0. So the range for square from -4 to +9 should be from 0 to 81, inclusive of 0 and 81. Got this? It's very important I set these ground rules because the point I'm making is you never treat inequalities as equalities. If you do what works with equalities and inequalities, you're going to get all questions wrong. But if you stay within the purview of these rules, right, things become a little easier for you to work, right? And the harder levels of questions, you'll understand how these will tie up. Okay with this, guys? So if you're okay with this, I can move on to the next bit and then we'll look at a couple of questions. Guys, okay with this? Can we move on to the next bit? Srinidhi, did you understand why it is not from 9 to 81, 0 to 81? Right? Perfect. Okay, can I move to the next one? Perfect. Done. Okay. Now, now this is what I call a very important concept. This is what I call the maximization and minimization concept of inequalities. Okay. Now there are two things you have to understand here. Very, very important, will come in handy on specific types of questions. The first is where do you use this concept? And the second is how do you use this concept? Now, where do you use this concept? Whenever you see a question where you're given two ranges, say one in terms of x, say minus 11 is less than or equal to x is less than or equal to 12. Given two ranges, so minus 8 less than or equal to y less than or equal to minus 3. So whenever you're given two ranges like this, and a question asks you to find the product of the values from the ranges, an addition of the values from the ranges, and a subtraction of the values from the ranges, then this is where your mind should go towards using the Maxmin concept. Okay. Why doesn't it work for division? Obviously, your question would be, but division is going to be slightly tricky because it depends upon whether the range I'm giving you for y includes 0 or not. Okay, so I'm just keeping division out of the purview of this because it's not going to hold good for all cases. But for multiplication, addition, and subtraction, this Maxmin concept will always work. So where do you directly think about this concept when you see two ranges, one in x, one in y, and the question asks you to combine it in terms of a product, addition, or a subtraction? Now, how do you use it? Very quick, very easy. Don't sit and picture things on the number line. Don't think of using combinations. Just place the inequalities one below the other. You see, I'm placing them one below the other. I'm first going to work for xy. Okay. Now, after I place the inequalities one below the other, I have to make sure that the inequality signs are pointing in the same direction. If they are not in the same direction, I can use the properties of inequalities and make it in the same direction. I can reverse the inequality. I can multiply throughout by negative, but I will always make sure that the inequality signs point in the same direction. And then I'm going to work for a product first. If the question asks me some information about the product XY, after I place them one below the other and the inequality signs are pointing in the same direction, all I have to do is perform that mathematical operation, that is multiplication, only between the extreme values. You see, like this, only between the extreme values. There are four extreme values. You would only perform the mathematical operation between the extremes. So let's do it. Minus 11 into minus 8 gives me plus 88. 12 into minus 3 gives me minus 36. Minus 11 into minus 3 gives me plus 33. And 12 into minus 8 gives me minus 96. You see, if I use the extreme values, I will get four possible products. Now, the good thing about this is the maximum value of these four values will be the maximum possible value for xy. And the minimum possible value of these four values will be the minimum possible value for xy. So what you end up getting by just multiplying the values and from the extremes is you're going to get a range of values for xy. So basically this entire term, right, tells me that xy should range from minus 96 to plus 88. Advantage of it, if you're finding the extremes, the max and the min, then everything in between should also be a possible value for xy. And the same thing would work for x plus y as well. The good thing about addition is you can do it directly. You don't need to find four values, but we'll just do the four values, no problem. Minus 11 minus 8 gives me minus 19. 12 minus 3 gives me 9. Minus 11 minus 3 gives me minus 14. And 12 minus 8 gives me 4. So this is going to be a min value. And this is going to be a max value. So now I know the range of x plus y should be from minus 19 to plus 9. You see, the Maxmin concept is very, very important. especially when the GMAT asks you for questions where you need to manipulate two ranges. Okay, and you have to manipulate it such that you get a product, addition, or subtraction. Okay, so any questions on this? Right, I'm going to move on to some questions now so that you apply these concepts onto, typical GMAT questions. So if you have any doubts, ask me now, because I'm going to move on to a PPT which has some questions and we can work them together. Guys, all of you are okay with this? No problems? Perfect. If you want me to work for x minus y, Shrey, same thing, right? So same logic applies. If you want x minus y, just follow the extremes, right? Minus 11 minus of minus 8 will give me minus 3. 12 minus of minus 3 gives me plus 15. Minus 11 minus of minus 3 gives me minus 8. And 12 minus of minus 8 gives me plus 20. So here's my max value and here's my min value, right? So the range of x minus y will be from minus 8 to plus 20. Got this? That's the advantage of this. It's very quick, but if you want to utilize this one, you have to make sure that the inequality signs point in the same direction. If they are not, you make it the same. Okay. Can you add or minus with any sign? Okay, so good question on that. See, one thing you need to understand, right, is uh, and this is a rule, you can always add inequalities. No problems. You can always add inequalities as long as the signs, inequality signs are the same. You can never, you can, you cannot subtract, multiply, or divide always. It's not possible. There will be certain cases where things are not going to hold. I'll give you an example. Okay, I'll just take like a set of inequalities. Say 1 is less than 2, 2 is less than 3. Say let's take a negative value as well. Minus 4 less than minus 2, minus 3 less than minus 2. And let's take one negative, one positive as well. Minus 4 less than 2, minus 3 less than, say, 4. So you see what I'm doing is I'm trying to vary the signs, okay? Before somebody asks me, what about this sign, this sign? I'm just giving you all three possibilities. What I'm telling you is you can always add inequalities. Blindly, you can add inequalities as long as the inequality signs are the same. If they're not the same, you make it the same and add them. So you see, I'm adding the inequalities. So 1 plus 2 gives me 3. 2 plus 3 gives me 5. So 3 is less than 5. Absolutely holds good, no problems. Minus 4 minus 3 is minus 7. And minus 2 is minus 4. Absolutely fine. Inequality is true. Minus 4 minus 3 is minus 7. 2 plus 4 is 6. Absolutely fine. Inequality is true. Now let's subtract, okay, and see if it holds in all cases. If it doesn't even hold in one case, no, I'm just going to ignore everything else, okay? Let's subtract. 1 minus 2 is minus 1. 2 minus 3 is minus 1. So minus 1 can't be less than minus 1, right? So it's not going to work out. Let's multiply. 1 into 2 is 2. 2 into 3 is 6. So this is absolutely fine. But you see the second inequality. Minus 4 into minus 3 is 12. But minus 2 into minus 2 is 4. So you see this is not going to hold. That is why I'm saying that the safest mathematical operation, right, you can perform with inequalities, provided the inequality signs are the same, is always addition. You can always add inequalities blindly. You can add inequalities as long as the inequality signs are the same. Okay, somebody asked me this, so I'm just putting it across. It's a basic property of inequalities that you're working with. How to work with three inequalities? No problem, right? A plus B plus C, no? Or you work with 2, find out AB, and then you multiply with C. It's like me giving you three equations, Satanand, right? If I ask you what is A into B into C, I'll first find out what is A into B, and I will combine A into B and C, right? So I'll get A into B into C. So it's still, if I combine A and B, I will get one inequality, and that I can combine with C, right? Yes, subtraction is only hold when the inequalities are opposite, right? Anudeep, that's the you know say exceptions to certain rules. So the point I'm making, right? Forget about the rules in terms of when subtraction will hold addition. The point I'm making is the safest mathematical operation that you use while working with inequalities is addition because it will always hold. Signs are the same means I mean inequality signs are the same, right? The inequalities have to point in the same direction. That's what I mean by the signs. Okay, when I say signs, it's the inequality signs that I mean. Okay, LP. Okay. Okay, with this guy. So quickly summarizing what we've discussed so far, I'm just again I told you, right? I'm going to build things and then I'm going to give you three golden rules, but I need these points to be in place before we go into those harder questions. Okay. Now, whatever we discussed so far, okay, I'm just going to recap quickly. First, the three basic rules: you can always add or subtract on both sides of the inequality, and the inequality sign remains the same. You can always multiply with a positive value; the inequality sign remains the same. You can multiply or divide with a negative value; the inequality sign will flip. You should never multiply or divide both sides with a variable until you know the sign of the variable. Don't multiply or divide both sides by x square because x square is not always positive, it is non and negative. Keep that in mind. Then when it comes to squaring inequalities, don't square inequalities directly, right? Picture the range on the number line and then figure out what the range of x square is going to be. And finally, when it comes to two inequalities or two ranges given to you, and the question asks you for a multiplication, addition, or a subtraction between the ranges, then you can always set the inequalities one below the other and use the max-min concept that is only working with the extreme values. Got it? So I've given you a quick summary of it. Now I have GMAT type questions here that deals with what we've discussed so far. Okay, and this would be the rules. I'm going to give all of you all 2 minutes to solve the question. And once the 2 minutes are done, let's have a discussion on this. Okay, I'm assuming all of you all can see the question here. Your time starts now. It's a very easy one. Should be done in like 30 seconds. Right. This is I'm going to start with levels of questions. So this would be my level 1 of difficulty. Right. Very simple. Okay. So let's have a discussion. Some of you all have marked D, but most of you all have got the right answer, and that is E, right? Guys, keep in mind, I'm going to work this question for you so that you understand where the traps lie. The trap answer would be D. Okay, this would be the definite trap. Now, what concept is this testing you on? It's important for you to know the concept, right? This question is just testing you on the basic concept that you can never multiply or divide both sides of an inequality with a variable until you know the sign of that variable. So what they've given me is BC is not equal to 0 and A is greater than BC. And the question asks me which of the following must be true. That means I need to pick one which is always true, right? I have A greater than BC, and my first statement gives me A by B is greater than C. Now, the question I'm going to ask myself, right, is how do I go from this equation to this equation? The only way I can go from this equation to this equation is if I divide both sides by B. Agree? And what happens when I divide both sides by B? Some people will say A by B has to be greater than C, so the first statement would hold. But you need to understand when you're going from this equation to this equation, you're dividing both sides by B, you have absolutely no clue about the sign of B. And when you don't know information about the sign of B, I don't know whether I have to keep this inequality sign the same or need to flip it. So here, I can have A by B to be greater than C if B is positive, or I can have A by B to be less than C if B is negative. Because if I'm dividing both sides by B and I don't know the sign for B, if I know that B is positive, I'll keep the inequality sign the same. But if I know B is negative, I'm going to flip the inequality sign. So the first statement is not going to be true always. And the same patterns go for the second. A is greater than BC. So the second statement gives me A by C is greater than B. The only way I can go from this equation to this equation is divide both sides by C. But since I don't know what the sign of C is, it can be positive or negative. I'll have to either keep the inequality sign the same or flip it. So A by C can be greater than B, but A by C can also be less than B. So it's not going to be always true. Out goes second. And the third one is also pretty straightforward. A by BC is greater than 1. The only way I can go from this equation to this equation is divide both sides by BC. And I don't know what sign BC takes, right? So I don't know whether I'm going to flip the inequality sign or keep it the same. So out goes 3, leaving me with my answer, none. The trap answer would be D, 1, 2, and 3. For people who forget the fact that you cannot never multiply or divide both sides with a variable until you know the sign of that variable. Okay, all of y'all. So that's this question. Um, Now, any questions on this? Anybody got what I said? Yeah. See, Shrey, if it was could be true, then obviously the answer will be D, right? But making this question could be true would become too easy, no? I mean, that would just basically reduce the difficulty level of this question, isn't it? Okay, guys, okay with this? See, a very simple question. You see how tricky it becomes? And for people who started putting in values, right, you'll realize that that's the worst way you can go, and approach this question, because they haven't told you what kinds of values you're going to work with in terms of A, B, and C, right? You can take fractions, you can take negatives, positives. The only thing I know is B and C are not equal to 0. Okay with this? So starting with a very simple one, just to get you on board, justify the first property I gave you of multiplying and dividing with a variable. Can we move on to the next one, slightly harder? Ravi, I'm looking at the comments as they come up, right? So if I miss out on a couple, no, please forgive me, right? I think the last comment you gave me was E, so E is absolutely right. Okay. If I miss some question, I'll give you some time in the end in the Q&A session, right? Because I'm also writing and also looking at the questions that you put up. So I'll keep a Q&A in the end, and you can bring back your questions again. Okay. Perfect. So I'm going to the next question now. A slightly harder one. Again, the same logic holds. I want all of you all to take 2 minutes. Your time starts now. Guys, think through this question, because if you don't think through, right, the inequality questions become tricky, right? Keep in mind what we just learned in the past, say 40 minutes or 45 minutes of discussion. Final 30 seconds. Okay, so let's look at our answers first. Um, so again, I've got like some E's, some A's, some B's. Answer is 0. Yes, Ankit. Good. Good. Most of y'all have not fallen for the trap, given me the right answer 0. And you'll understand why I spoke about squaring inequalities, right? You see how nicely and intricately, the GMAT would test you on things like this, right? So, two things are tested here. One is how you square an inequality, and the second is you'll realize how the maximum concept will give you things very quickly. And the answer choices here, no, are a big pain, because all the answer choices are nicely drafted so that you end up getting those values at some points, but you'll have to be very smart in what you pick as your official answer, right? So I have minus half is less than or equal to x, less than or equal to minus 1 by 9. And I have minus 1 by 4 is less than or equal to y, and less than or equal to 1 by 25. And the question asks me, what is the max value of x into y square? Now it's asking me of x into y square, right? So instead of doing a two-step process, no, of x into y, the fastest process would be I directly find out what would be the range for y square, since I've been given the range of y. Now, for those who got, B as an answer, one, you have not squared things correctly. Second, you must have made a mistake in your entire analysis of x into y square in the end. Okay. So if I'm going to plot this on the number line, right, you're going to have minus 1 by 4, you're going to have 0, and you're going to have 1 by 25. You see, one is on the positive axis and one is on the negative side. So basically, you're considering all values from minus 1 by 4 to plus 1 by 25, and you're crossing 0, keep in mind, and you're squaring all of them up. So if you're squaring all of them up, right, the greatest value you're going to get is going to be when minus 1 by 4 is whole square. So I'm going to get 1 by 16. And the smallest value I'm going to get is going to be when 0 is squared up, right? So the range of y square should be from 0 to 1 by 16. And once you get this, this would be the most important bit. Solving the question now becomes like a piece of cake, right? Many of you all, if you have made a mistake, you'll have taken 1 by 25 on this side and you'll have worked with it. And keep in mind, guys, for people who took the 1 by 25 on that side and told me 1 by 32 is an answer, you should contemplate whether which of these two is greater. Minus 1 by 32 is greater, or minus 1 by 5625 is greater, right? You have to keep this in mind for those who fell for the trap. For those who didn't, right, and squared and got the range of y square very quickly, all you had to do was put it below, or even for at this point, right, if you can analyze the equation, that is also fine, but I would put it below one below the other. And since it's asking me for x into y square, I will work with the extreme value. So half into 0 is 0. 1 by 9 into 1 by 16 is 1 by 144, minus 1 by 144. Minus half into 1 by 16 is minus 1 by 32. And minus 1 by 9 into 0 would be 0. So I know the max value has to be 0 and the min value has to be minus 1 by 32. So since the question asks you for the maximum possible value of xy square, I'm going to pick 0 as an answer. Okay with this, guys? All of y'all? Yes. So you have to be slightly careful, okay? Because you see on the GMAT, no, this is what they would do. They would draft the answer choices, right? With say they would preempt what students would do, right? And what mistakes they would make, and then they would put the answer choices based on that. Okay. So any doubts on this? Prativa, I think my full screen is being seen, so I'm assuming you'll be able to see it, right? So if you're not able to see it, this is what I've done. Okay. Any question, guys, on this? All of you are okay with 0 being an answer? Anybody still not okay? Anybody with minus 1 by 5625 or minus 1 by 32 or minus 1 by 144, right? So minus 1 by 32, keep in mind, would be the min possible value, right? So you have to be a little careful while squaring the range for y square. Okay with this, guys? All of y'all? Perfect. Can we move on to the next question and then move on to 3 very important strategies on solving data sufficiency questions? Okay, so just one more question just to reinforce what we've discussed, and then let's move on to good 700 level ones. Okay, so here's your third question. A data sufficiency one, since the last two were both problem solving. Again, same thing applies. Your 2 minutes start now. Very simple answer to it, so not too much of issues. Shouldn't take you too much of time. Very quick question, just for you to get onto the bandwagon of using the Maxman concept. Okay, I'm not giving you too much of time on this. It's a straightforward E, right? For those who got C, then I'm assuming you're only considering numbers to be integers, right? That's one common trap that most of y'all would have to try to avoid, right? Don't fall for a trap of assuming that all numbers are integers here. So the question is straightforward: is xy less than 6? I mean, the first two statements don't actually give me anything. The first just tells me information about x. I don't know why. The second gives me why I don't know x, so I can knock off A and B directly, right? But when I combine the two together, right, and this is where my mind would directly go towards using the Maxman concept, I'm going to use Maxman by multiplying the values from the extremes. So half into minus 10 is minus 5. 2 by 3 into 10 is 20 by 3. Half into 10 is plus 5. And 2 by 3 into minus 10 is minus 20 by 3. So the range is from minus 6.66 to plus 6.66. Keep in mind, nowhere in the question have they told you that xy is an integer. So if I get this entire range when I combine the two statements, xy can be less than 6. So it can give me a yes. And xy can also be slightly greater than 6, right? You can have something like a 6.10000, 6.00001, depending on what values you take for x and y. So that gives me a no. So clearly, E is a winner here. Got it? Just three, four questions just to get you on the bandwagon of saying these are the rules. You have to stay within the purview of the rules and work with that. Okay, great. Now, perfect. Now I'm going to come to three very, 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 very important, I would say, golden rules of solving inequality questions. Okay, and this actual golden rule, no, is obtained from something called a quadratic inequality concept. If you ask me what is the most important concept of inequalities which makes your life simpler, it would be this quadratic inequality concept, because it has so many applications that it just reduces your working like tenfold. Now, all of you know what a quadratic equality is, right? Anything in the form of ax square plus bx plus c is equal to 0. So any quadratic inequality would be in the form of ax square plus bx plus c is less than 0 or greater than 0, or less than or equal to, greater than or equal to, right? Any inequality used with a quadratic is a quadratic inequality. And these are the types of equations that when you encounter, right, on harder levels of questions, you can actually break down. And this is how you break it down. It's a very simple concept. So I have x square minus 5x plus 6 is less than 0, right? Say, and I ask you to solve for x, right? Some of you all might know it, some of you all might not. So I'm going to explain this to you. Remember what we already established so far is don't work with inequalities the same way as you work for equalities, right? There are certain rules as well here. But the way you solve this, no, gives me two pointers that I want you to add, and these are like golden rules that you have to follow when you solve inequality questions by using analysis. The first, always keep the right hand side of the inequality as 0, right? If it is not 0, you take things from the right hand side to the left hand side, right? Simple. But always try to maintain the right hand side of the inequality as 0. You see what I've done here? The quadratic inequality is in that form itself. Second, simplify or factorize the left hand side to a product or a division of values. This is the most important. This is how you work with an inequality question. The key to solving any hard inequality question is how you spend time on the question stem. If you're able to spend time on the question stem, not jump into the statements, and try to break down the question stem by keeping the right hand side as 0 and simplifying the left hand side to a product or a division of values. Now, why? Now, obviously, the question will be, why are you simplifying into a product or division of values? Because analysis would be easy for me. Think about it. If I give you xy to be greater than 0, all of you all, right, without any qualms, would tell me that x and y have to have the same sign. You see, because products, no, and divisions are very easy to analyze because you only have to worry about signs. But if I mention x plus y is greater than 0 and I ask you to analyze this, then another added factor would be, in addition to you working with signs, you'll also have to work with the absolute values of x and y, right? The actual values, right? You can't directly just say that the two signs can be positive and so on. Let's work with it. Let's see. So for x plus y to be greater than 0, you can definitely say both x and y are positive. You can also have this case to hold when x is positive and y is negative, as long as the magnitude of x is greater than the magnitude of y. For example, x is 4 and y is minus 2. You can also have a case when x is negative and y is positive, as long as the magnitude of y is greater than the magnitude of x. right? So you realize, you see, when I set the left hand side as an addition, right, you see these extra steps of analysis that I'll have to do, because I'm not only working with signs now, I'm working with magnitudes. That is why setting the left hand side as a product, right, has its advantages, because you can actually analyze things faster. So here also, no, in the quadratic inequality, I'm going to simplify this. This is a perfect quadratic equation, right? So I'm just going to write it as x minus 2 into x minus 3 is less than 0. So you see what I've done? I've kept my right hand side 0, first golden rule. I've kept the left hand side as a product or a division of value, second golden rule. I will come to the third golden rule sometime later. Now, this is what I have. Now, this is where many students go wrong. They treat this as an equality and they say either this has to be less than 0 or x minus 3 has to be less than 0. Now, that's completely wrong, because you're doing exactly what you do with equalities, right? When you have an equal to 0, obviously any one of them can be 0 or both of them can be 0. But when you have this product, right, to be less than 0, then it depends upon the signs of both these quantities. That means one has to be positive, the other has to be negative, or one has to be negative and the other has to be positive. So what people will do, one way of solving is they will take different cases and they will work with those cases. But the quadratic inequality concept says, right, that if you actually picturize the entire quadratic equation on the number line by placing the roots on the number line, you see what are the roots here? Plus 2 and plus 3. Actually, in terms of math, these are what we call critical points. Okay, you basically place the roots on the number line, and what you do by default, blindly, without thinking, start with the extreme rightmost region, and by default place the sign or maintain the sign of the extreme rightmost region as positive always. And then what you do, you move from right to left, switching between the signs in each of the regions. You see what I'm doing? I'm placing the roots on the number line. I'm starting with the extreme rightmost region. I'm keeping the sign of that as positive. And then I'm switching from right to left, or I'm moving from right to left, alternating between the signs in each of those regions. Okay, this is actually what we call, this is my version of what we call the wavy curve method. Okay, it's actually a sine wave like this for those who understand, analytics slightly, but it's a sine wave like this. Now, your question obviously will be, why are you always keeping the right hand side as positive, right? Now, the reason we keep the right hand side as positive, let's bring in logic here. Let's take a value to the right of 3. Let's take 4. Let's put it back into this equation, the main equation. You see, 4 minus 2 is going to give me a positive value. 4 minus 3 is also going to give me a positive value. So two positives multiplies to each other will always give me a positive value. So any value to the right of 3 will give me a positive product. But take a value in between 2 and 3, right? 2.5. If I put 2.5 into the main equation, then I'm going to get 0.5. And here I'm going to get minus 0.5. So it's one positive and one negative. So I'm putting negative, you see. And then if I take something to the left of 2, say 1, and I put it in this equation, 1 minus 2 is negative, 1 minus 3 is negative. So negative and negative gives me positive. So you don't need to do all of this. I'm just saying by default, right? Start with the extreme rightmost region, place that as positive, and then move from right to left, switching between the signs. And the solution to this entire equation, right, will depend upon this right hand side of the inequality. What is the right hand side of the inequality? It's less than 0. So if the right hand side of the inequality is less than 0, your solution should be in the negative portion of the number line. And what is the negative portion of the number line? X should be in between 2 and 3. You see, it's less than, so I'm maintaining the less than signs in both cases. And that is what the quadratic inequality concept is. It's a very important one, will help you simplify questions very quickly. Okay with this, all of y'all? Any doubts? Make sure you, guys, all of y'all, no problems? Okay with the quadratic inequalities, or any doubts in that, right? I'm just telling you that this is a very important process, and I've given you two golden rules of inequalities. Always keep the right hand side as 0 and simplify or factorize the left hand side to a product or a division of values. These two pointers along with this are really important. You'll realize when we work questions, right, how important they become. So make sure you understand this fully before we go further. One more example. Okay, let me take it. So let's take greater than this time, right? Since I'll just directly write this. Suppose you have, let's take three equations. Okay, let's take a cubic equation. And the point I'm making is you can utilize this as long as you have one variable and you're able to put roots on the number line. So x minus 3, suppose I tell you solve for x, right? And it says x minus 3 into x plus 2 into x minus 4. Let's take greater than 0 here. Okay. Now you see this is nicely in the form that I want. The right hand side is 0 and the left hand side is a product or a division of values. And it has only one variable. It's a cubic equation. I'm going to directly take the roots on the number line. See, roots is what you would do if you have equal to 0. So if I'd given you this to be equal to 0, what would be the values of x that you're going to get? So the three values of x you're going to get is minus 2. I'm going to place that. Plus 3. I'm going to place that. And plus 4. Now here we have three roots. Very simple again. Start with the extreme rightmost region. Place that as positive by default. And switch between the regions from right to left, alternating between the signs. See, plus, minus, plus, minus. And now I look at the right hand side of the inequality. The right hand side is greater than 0. So if it's positive, my solution should lie in these positive portions. You see the positive portions, I'm marking it for you here. So what is the first positive portion here? X should be greater than 4. Or the next positive portion, X should be in between minus 2 and 3. Quickly, this would be my solution of this entire cubic equation. You see, one step I get to my answer. That's the advantage of a quadratic inequality. It's not only applicable for quadratics, you can utilize it for cubic, fourth power, fifth power, as long as there's one variable and as long as you can get roots of that equation. Okay with this, guys? For those who are not clear in the first case, yeah, works with anything, Renato, right? I'm just giving, you can take fractions as well and do it, as long as you put the regions correct and you put the fractions correctly on the number line, huh? Okay with this, guys, all of y'all? Very important, because I'm going to make a couple of points, add to the two golden rules, give you a third golden rule, and I'd give you some more points when we work with questions. Okay, and I'll show you how I would analyze questions and make things easy. Okay, if you're okay with this, I'm going to move on to the next bit. Perfect. Done. So think about it. Okay, I'm going to rewrite the two golden rules first. Always keep the right hand side as 0. Second, simplify or factorize the left hand side as a product or a division of values. Right? I'm going to add to this, but there is one thing that I want you to understand, and that is this. Okay, the key to solving any inequality question, especially on data sufficiency, is to always learn to spend time on the question stem and learn to break down the question stem. So why did I give you the quadratic inequality process? Because sometimes in the question stem, know what they ideally do in an inequality question, they'll give you a complex equation. And what they'll expect you to do is to, break that entire complex equation down to a very simple form. And they're just giving you simple information, but in a complicated form just to confuse you. So the clue, right, and the best way to approach things is to always spend time on the question stem. On any inequality question, the question stem is key. If you break down the question stem and you rephrase the data sufficiency, your work is done. So how do you break down the question stem? By keeping in mind these two golden rules. I'm going to add a third one. The third golden rule that I follow is always maintain squared terms or even powered terms. You see what I'm asking you to do in the second step? In the second step, I'm asking you to simplify or factorize the left-hand side of the product of division of values, right? Let's take an example. Say I have something like x square is less than x. So this is how the GMAT would give you statements on a data sufficiency. They'll give you some complex information which you can actually break down. Now, what people will do now is they'll go on plugging in values here. What I will do is I'm going to take the right hand side to the left hand side, make the right hand side 0, and I'm going to simplify the left hand side to a product or a division of value. So x into x minus 1 is less than 0. Now this is in the absolute nice quadratic inequality form that I want. So I'm going to put the roots, which is 0 and 1. I'm going to start with the extreme rightmost region, plus minus plus. The right hand side is less than 0, so my solution should lie in the middle portion. So the solution here is, or the information they are giving me is x has to be between 0 and 1. And if you look at it logically, no, it would make sense, right? Because the only way you can have a square to be less than a value is when you have a fraction between 0 and 1. But if you have something like this, right? X cube is less than x square. You know what I'll do? I'll do the same thing. I'll take x cube minus x square is less than 0. But I'm going to factor out an x squared term. So x square into x minus 1 is less than 0. Now the good thing, right, is when you factor out a squared term, you know what the sign of that squared term is always going to be, or the sign of the even power term. It's like me telling you x square y is less than 0. So most of you all will say, okay, x square y is less than 0 means x square will always be positive, constrained to the fact that x should not be equal to 0. I'm keeping that in mind. And I know that I'll have to work only for the sign of y. So y here has to be negative. So same here, right? Once I'm able to factorize out an x squared term, I know the sign of that squared term will be positive, taking into consideration that x is not equal to 0. So I'm keeping this in mind, right? I'm taking this to be positive, knowing that x should not be equal to 0. And I know for this entire equation to be less than 0, the sign will depend upon x minus 1. So x minus 1 has to be less than 0. So x should be less than 1. And you see the solution is x is less than 1, but it also includes 0, right? So I have to remove the 0 by saying x should not be equal to 0. Got this? So whenever you have a squared term, right, always maintain squared terms, even power terms, because the sign of that term will always be known as long as it doesn't take a value of 0. But you see how I set up my equation? I always said that a squared can always be positive. No, Anudeep, if it's two variables, unfortunately, you cannot do it. You'll have to work with analysis at that point, okay, with two variables. They're forcing you to work with analysis with two variables, right? Okay, guys, so this is the third golden rule. Always maintain square terms or even powered terms. And keep in mind, learn to break down the question stem and rephrase the data source. See, if you spend time on the question stem, now the statements become slightly easier for you to work with. Okay, so since this is clear, I'm going to go now to the harder levels of questions. And here's question 1. It's a 700 level question on the GMAT. So I want all of you all to take 2 minutes. Give me an answer, please. Time starts now. Guys, keep in mind, focus on the question stem and focus on the three golden rules that we discussed. Your answer will come in quickly, right? Don't make it complicated. Never go the route of plugging in values. Plugging in values should be a fallback approach that you only think of using if analysis fails. Okay, last 30 seconds, guys, and then we'll have a discussion. Right, see, if you're not getting an answer, right, pick the best possible one and put it in the chat window. So when we discuss, no, let's see at what point you got stuck and you get a holistic understanding of things. Okay, so let's look at the different answers. Okay. Good. Most of y'all have given me a good answer, right? You see, you would have understood, right? Those who have given me the correct answer B, I'm impressed by a number of people who've given me that. You'll realize how important it was to break down the question stem, right? And how important it is for analysis to keep the right hand side zero and to maintain square terms. For those of you who have given me A, let's look at why A would not be sufficient. Shrey guessed B. So Shrey, if you've guessed, let's see why you've guessed. Okay. And some of you all have given me E as an answer, but I'm sure for those who gave me E as an answer, right, you'll have not spent time on the question stem. So let's work with it. Okay. Keep in mind what I said. So the question is 1 by x minus y less than y minus x. Most test takers jump into the statements at this point. Don't break down the question stem. So I'm going to keep the right hand side 0. So 1 by x minus y minus of y minus x is less than 0. I'm going to keep the left hand side as a product or a division of values. But I see here, for me to take an LCM, right, I see there's an opportunity for me to get a whole squared term. Wherever I see there's an opportunity for me to get a whole squared term, no, I will take that opportunity because the sign of that entire term is known to me. So what I'm going to do is I'm going to switch the variables here. Okay, so it's going to be 1 by x minus y minus of minus, so it will become plus x minus y is less than 0. You see what I'm doing? I'm taking minus out common from this term. Now I'm going to take the LCM. So x minus y and 1 plus x minus y whole square is less than 0. And this now is my question stem, which I've set up very nicely conducive to analysis. The right hand side is 0 and the left hand side is a product or a division of values. Now, for me to have this left hand side to be less than 0, logic says that I need one of the numerators and denominators to be positive and one out of the numerators and denominators to be negative. But if you look at the numerator, right, and this is the advantage of keeping the whole square term there because the sign is known, the entire numerator I know is always positive. So for me to prove this equation to be true, I need the denominator to be negative. So what is the question? What is the hidden information that the question is actually asking me to find? Is x minus y less than 0? Or basically, is x less than y is the question. This is what the simplified question is. Right? So if I go to the first statement, x square plus y square, I'll directly take the 4xy on the left hand side is less than 0. So what I can do here is I can write this as x plus y whole square, right? Or x minus y whole square minus 2xy is less than 0. Agree? So you see what I'm doing? I'm just splitting this minus 4xy as minus 2xy minus 2xy, right? And x square plus y square minus 2xy is x minus y whole square minus 2xy. So you see this is a positive value, right? So some positive value has to be less than, I'm taking the 2xy this side, 2xy. So 2xy has to be greater than some positive value. But you see, I just know that 2xy has to be some value greater than a positive. But I don't know whether x is less than y here or y is less than x, right? I don't get any information to answer the question. It gives me a yes because x can be less than y. It can also give me a no because x can be greater than y. So the first statement is clearly insufficient. You see, what I'm doing is I'm only playing around with the signs. I'm not worried about putting in values. And that's the advantage of whole square terms, right? Because you know the sign of it will always be zero or positive. Correct? And the second statement is like a lollipop statement for me, right? So y is less than x basically tells me that x should be greater than y. And this statement is answering the question with a definite no. And remember, a definite no is also a definite answer. So the answer is B here. Okay with this, all of y'all? Good 700 level question. The key to break it down is to spend time on the question stem. Okay. So any doubts I would want to know, especially the guys who gave me E and A. Did you understand when you broke down the question stem? You know, you literally solved the question at that point. But you see, I still went and ahead and solved for the first statement. I didn't just let it go saying that it's not possible. I tried to answer the question with a yes or a no. Okay with this, guys? All of y'all? No problems? Any doubts on this, or can we move on to the next question, right? And that would be the last one that I have, so that we wrap it up and I give you some time for some maybe 5 minutes for Q&A in the end. Any doubts in this, guys? All of you all okay with the three golden rules for you to make your entire question stem conducive to analysis? If you're okay with that, we're going to work with the question. Perfect. Perfect, Anudeep. So let's try it on one more question so that you get a holistic understanding of things, guys. Right? I have two questions here, but I think we'll have only time for one. So let me move on to that question. And yeah, let's work with this. Okay. Very simple one. A good complex one. But remember what I told you? Spend time on the question stem. The answer will come to you very quickly. Okay. So your time starts now. persist with the question stem, okay? Do not let it go beyond the point. Spend time on it and simplify it based on the three golden rules. Final 30 seconds. Okay. So let's look at your answers first. Okay. D, some with B, some with D, lots of B's, but lots of D's as well. The others, I'm waiting for some more answers. Take your time. Please put in the best possible answer you can, right? Okay. Found this hard? Found this question slightly tricky? Too much of calculations in the question stem? Okay. Okay, so I'm going to work with this, okay? Now what catches my eye, right? And this is what I'm trying to do is I'm trying to give you like an insight into how my mind would work, right? What catches my eye is the fact that they have given me that x and y are positive integers, right? So if they are positive integers, no, people who are comfortable with plugging in can also plug in, but I'm not going to use plugging in here at all. I'm just averse to plugging in. That's the worst way you can work an inequality question. But when signs are given to you, no, when you see things like this given, remember you can always manipulate or you can always simplify using using the variables. You can actually multiply or divide with those variables, okay? So ideally, your working will become easier if you multiply or divide because you know the signs of the two as positive. But even if you didn't identify that, right? You use what I told you, keep the right hand side as zero. That also would work. So I'm just going to stick to what most of you all would have done rather than adding another dimension to things. So I'll just take the 2 plus y divided by the 3 plus x onto the left hand side, and this would be greater than 0. So I'm going to take the LCM, that's 3 plus y into 3 plus x, and this will be 2 plus x into 3 plus x minus 2 plus y into 3 plus y greater than 0. I'll open the brackets because there's options for me to cancel things out and simplify. So I'm just going to do it directly. 6 plus 5x plus x square. Remember, minus applies to everything here. So minus 6 minus 5y minus y square divided by 3 plus y into 3 plus x is greater than 0. So I'm going to cancel the 6 and minus 6. And what I'm left out with is x square minus y square. You see how I'm grouping the terms, okay? And this is what you'll have to do. This is where your algebra skills will come into play. Divided by 3 plus y into 3 plus x is greater than 0. You see what's common? I'll always try to see, I'll not leave the numerator or denominator with an addition. What happens with additions and multiplication? Now, again, it gives me an additional level of analysis. So if there is an option also for me to take things common and make it into a product, now I'll take it. So x square minus y square is x minus y into x plus y. And I have plus 5 into x minus y divided by 3 plus y into 3 plus x is greater than 0. Okay. I'm just writing it to the left because I don't have space. So I'm taking x minus y common, and I'm left with x plus y plus 5 on the numerator, and I'm left with 3 plus y into 3 plus x greater than 0 on the denominator. Now my entire question stem is nicely set up, conducive for analysis. You see, I've kept everything as products because products are easy for me. I need signs to work with. And this is where the constraint here comes into play. Many people, right, forget the constraints. Remember, the constraints are very important. Here they're telling me x and y are positive integers. Now think about it, right? If x and y are going to be positive integers, this entire portion of the numerator, x plus y is positive. 3 plus y is going to be positive. 3 plus x is going to be positive. So the entire denominator is positive. And for me to have, if the entire denominator is positive, for me to have this division to be greater than 0, the entire numerator has to be positive. And x plus y plus 5 I already know is already positive, right? So the only thing I have to worry about is whether x minus y is positive or not. So the question now is basically asking me, is x minus y greater than 0? This is what it is. If you do this, your answer quickly pops up at you, right? The first statement clearly is not sufficient because x plus y is equal to 3 doesn't tell you whether x minus y is greater than 0. I can take x as 2, y as 1, or I can take x as 1, y as 2. So clearly insufficient. But the second statement spoon feeds me with what the answer is going to be because this gives me x minus y is less than 0. So the answer here has to be B. Okay with this? You see what I did? I spent time on the question stem, and that is key to solving any data sufficiency question. Vijay, you don't need to proceed with it, right? See, the reason why I'm doing it, right? You look at it from my perspective, right? I would actually stop with the third and fourth step, right? And I would analyze it just as what you said. But when I'm explaining it over a portal, no, not everybody would give you would understand if I'd stopped at that step and then continued with the analysis, right? So just for everybody else to understand, I've done the extra 2 bits. I understand what you're saying. I would have done exactly the same as you. Okay. Yes, Anudeep, the key is always reading the question stem right. Okay. The problem with inequalities, no, is because there's so many pieces of information that is running in the question, you'll forget the question stem. Yes, Indranil, that is exactly what I'm saying, right? Because we have x and y to be positive, no, I would definitely have cross multiplied. Okay, that is how you simplify your calculations. But I did it because I'm sure, right, most of you all didn't realize that you could have utilized that to your advantage. So I did it how most of you all would have thought of doing so. Okay, ideally I would definitely cross multiply, made my life much more simpler. Okay with this, guys. So that's the 3 golden rules of inequalities, and that's what I have for my webinar. I've actually, gone way past my time, so I'll give you a quick 5 minutes of Q&A. You can ask me anything, and before we, wrap up, if you want more such strategies, right, please go and log into our website, right, crackverbal.com, because I've written a very nice ebook on the rules of inequalities. Okay, I've written a very good ebook on the rules of inequalities, and all of this, right, can be like a reference of sorts, and each of the rules are given with an example. So you can go to the ebook section and you can download it, please. Okay, perfect. So guys, any quick Q&A, quick questions that you would want to ask me, and then we can wrap up. We've already shot way past the time, but I'll still give you 5 minutes for a Q&A. Any lectures soon of any other topic? Ankit, maybe I have another lecture scheduled sometime at the end of the month, and that would be some data sufficiency strategies. Okay, so I think the date will be mentioned, and the link will also be shared once um, the day comes up. Okay, but the end of the month is what I have scheduled for one more. Right. So, guys, any last questions before I wrap up? It's already pretty late. Perfect, Shweta. Just see the reason why I gave you this, right? Just make sure that you stick to the straight and narrow of applying those concepts onto questions. Trust me, right? It's going to help you on almost 95% of the questions. Okay. Bhupinder, explaining that concept again, it's going to take around 5 minutes. So you can actually go through the video. I think you would have this video on YouTube, or the link would be provided to you, so you can actually look at the recording, right? Any session on probability. I'll see, Rahul. So okay, if maybe there are more sessions scheduled, I may, I'll take something as probability. Perfect. Okay, so guys, I'm going to log off now. I hope what we discussed today helped you all, give you a different perspective of how to solve inequalities. It is my favorite topic, inequalities and absolute values. Because I absolutely love critical reasoning and analysis, right? So it actually falls in my alley. So I hope it helped you, and I hope to see you again, right? And the last question I went as extracting X and Y strategy didn't work. How to crack? See, Vimal, it's more to do with your comfort with how to simplify equations. Okay, so whenever you see the patterns of x square minus y square, no, it's always better for you to simplify into x minus y into x plus y. Perfect, guys. So good night. I'll see you next time. Thank you so much, and a great thumbs up to GMAT Club for giving us this platform also, right, to connect with you guys, right? Hope to see you again. Good night. Bye. Take care.